This lesson is called Interior Angles of Polygons, and it's the beginning of a new section for us where we're going to start working with different polygons. Okay, so first, the definition of a polygon. A polygon is just a closed figure consisting of line segments called sides, which intersect with other sides at their endpoints, forming vertices. Okay, so a triangle, okay, that's actually a polygon as long as there's no curves and as long as it's a closed figure. It's going to be a polygon. Okay, we'll talk about different types of them later, but you know, a square, all polygons. So now we're going to name these polygons. Okay, so we'll start with a three-sided, three-angled closed figure. It's a triangle. A four-sided, four-angled closed figure is a quadrilateral. Then a five-sided, five-angled figure is a pentagon. So you're going to need to know the names of the first 12 of these, and then we'll let you know how you can name the rest of them beyond 12. There are actual names for them going up way past 12, but we don't need to know those. Okay, so then we get to a six-sided, six-angled is a hexagon. This next one, 7, this one isn't as common, but you do need to know it. And for some reason, the 7-sided has two different names. So let me give you both of them. It can be called a septagon or a heptagon. Don't know why it has two names, but it does. Then we have the 8-sided, 8-angled. Most people are familiar with this from a stop sign, an octagon. 9-sided, 9-angled is a nonagon. 10-sided, 10-angled. This one's kind of common too. This is a decagon. Deca, meaning 10. Okay. Now let's continue. Hopefully you can pause if you need to get them. Now the 11-sided, that one's not that common, but it is called an undecagon. That's 11. And then a 12-sided, 12-angled is a dodecagon. Okay. Now beyond that, any polygon that has more sides than 12, you can just call an n-gon. So in other words, if it has 36 sides, it's a 36-gon. If it has 20 sides, it's a 20-gon. So you can just name it by the number of sides, anything beyond 12. Okay. All right. So now we come to the definition of two different types of polygons. We have convex and concave. The convex ones are the ones that we are going to be familiar with and the ones that we're going to work with and that we're going to provide formulas for. And it's a polygon with interior angles that each measure less than 180 degrees. Okay? Now a concave polygon has at least one interior angle that measures more than 180 degrees. In this picture you see this angle interior right here. That is more than 180 degrees. So it can have more than one, but just having one is enough. Another way is if you can draw a line from one vertice to another and it goes outside the polygon, that's another way to see that it's concave. And you can think of it as the side kind of caves in on itself. So if it caves in or if it has that one interior angle that is more than 180 degrees, it is called concave. And all you really need to know about concave is how to recognize them, because those do not fit the formulas that we're going to talk about. We're only going to deal with convex. Okay? So now here is a formula that you're going to use a lot, and you need to memorize this one. The sum of the interior angles of the sum of the measures of the interior angles of a convex polygon with n sides is, n minus 2 times 180, where n is a number of sides. So in example 1, this is a decagon, which means it has 10 sides. So 10 minus 2 times 180, or 180, or just 8 times 180. And so my calculator, eight times 180 is 1,440 degrees. Okay, so there's nothing tricky about these. You just need to know that formula. Find the sum of the interior angles of a 20gon. Well, if it has 20 sides, that is 20 minus 2 times 180, or 18 times 180. 18 times 180 is 3240. So the sum of the interior angles of a convex polygon with 20 sides is 3,240. Okay, let's look at example 2 now. This is a little different. It says find the missing angle. Okay, so we have a polygon here. The first thing you want to do is count the sides. 1, 2, 3, 4, 5, 6. So it has 6 sides. Okay, so what I want to do is determine what should all of the angles add up to. So 6 minus 2 is 4. So 4 times 180. So that is 720. So all of the sides should add up to 720. So all I need to do is add up all of these and then subtract that from 720. So I'll use my calculator, and I have 130 plus 130 plus 90 plus 130 plus 120 equals 600. So 720 minus 600 equals 120 degrees. That means this angle here is 120 degrees. Okay. So please look at example 3. Count the sides. 1, 2, 3, 4, 5 sides. So it has 5 sides. So I do 5 minus 2 is 3 times 180. 3 times 180 is 540, I believe. Yes. So 540. Now I'm going to subtract the angles that are there. But then let's see. I have 2 that are x. So maybe, let me, what I'm going to do is I am going to write, I have these 2 x's. So let me write that as 2x plus, and then add 120, 120, and this one is 90. So all of the angles add up to 2x plus 330, and that is equal to 540. So now let's just solve the equation. Subtract 330 from 540, and I get 210. So 2x is equal to 210, and if I divide by 2, I get 105. If you want to check your answer, go ahead and add them up. Add up 105, 105, 120, 120, and 90. And you'll get 540. So you can check your answer that way. Okay, now let's look at the quick check. Little different here. If the angles of a convex quadrilateral are x, 2x, 3x, and 4x, what's the value of x? Let's think about this. I'm not going to try and draw this to scale, but I am going to just draw a 4-sided figure. Okay, I mean, that looks like a rectangle, and that's obviously not what this one should look like, but it just helps me to put it in perspective where I can put these x's in my angles. So one angle would be x, another angle would be 2x, another angle would be 3x, and another angle would be 4x. So I know that all of the angles in a four-sided figure, that is 2 times 180, has to be equal to 360. So just add your x's. I have 4, 7, 8, 9, 10. So I get 10x is equal to 360. And if I divide by 10, I get x is equal to 36. Okay, I know my picture doesn't match, but x is equal to 36. Okay. So now let's look at example 4. Okay, now this one is, it's really a lot of the same, but a little more detail in here. Let's see, here's a 90-degree angle. Let's count our sides. 1, 2, 3, 4, 5, 6, 7 sides. So I have 7 sides. So that is 5 times 180. Okay. 5 times 180 is 900. So they all add up to 900. So let's add our x's. 4, 8, 12, 18, 24. So I just added all my x's, and I have 24x. And then let's add our numbers. I have 120 and 90. That's 210. I'll write that right here. But then I have a minus 15 and a minus 15. So I need to subtract 30 from 210. So 210 minus 30 is 180. So 24x plus 180 equals 5 times 180 was 900. Okay. All right, so there is my equation. So if I subtract 180 from 900, I get 720. And then divide by 24. And x is equal to 30. Now, sometimes they might go back and ask you what are the angle measures themselves, and if they did, well, we could just take 4 times 30 is 120, 120, 120. 6 times 30 would be 180 minus 15, so be 165, and so on. So sometimes they might ask you to go back and fill in the actual measurements. All right, let's look at the next part of this. A regular polygon. One second, let me see how much is left. Okay, let me go ahead and stop this video here. There's not that much left, but I don't think I'll have time to finish, so I'll put it on a second one. So I'm going to pause here.